Okay, so here's a little different problem here. It looks pretty straightforward, but it's pretty involved. You're given a function, and you want to find the tangent lines that are tangent to this function that go through this point, where this point is not on the curve. Well, how do I know that? Well, let's just take -1 and plug it in, and we're not going to get -4, so this point's not going to be on this curve. So this is -1 cubed plus 4 times -1, which is -1 minus 4, which is equal to -5. So therefore, when when x is -1, -5 is the point that's on this curve. So we have a point that's not on the curve. I want to find the tangent lines that go through this point, tangent lines, there are two of them, that are tangent to this curve. So we need to figure out what are those tangent lines, what are the x values, and then what are the equation of the tangent lines. So I've created a visual here using Geometry Sketchpad. Here is my function, f of x cubed plus 4x, and then here is the point -1, -4, which you notice is not on the curve. So I'm going to create a tangent line. I'm going to create a line that goes through -1, -4, and notice that this line could go in many different places, and it looks like it's tangent somewhere down there. It's -1/2, it looks like, and then another one's right around the origin. Well, I've already created those values because I know what the answer is, so I'm going to show the actual points. So these are the 2 points where the tangent line is tangent to the curve f of x. What are the 2 x values? Well, the first one is at 0. So notice if I put that point right around the origin, it looks like it's tangent, and it's tangent to the curve, and it's going through the point -1, -4. And then the second tangent line is down here. I'll do my best to put it on top of the other one. And you'll notice it goes through -1, -4, and it's tangent to the curve down here at -1.5. I think this is like -9.375. This is the closest I could get it to it. So we're going to get 2 different x values, and then we're going to need to determine the equation of the tangent line. So the equation of this tangent line and then the other tangent line. Oops, I just moved that point. Wrong one. The other tangent line, what is the equation of this tangent line that goes to the point 0, 0? Okay, so let's go back to the work. So in order to form a tangent line, you need an x value, a y value, and then we need to know a slope because we're dealing with tangent lines. Well, what is slope? Slope in calculus is just derivative. So let's look at derivative. So this is going to tell us what is the derivative, what is the slope that goes through these points. So we have a slope, we have an x value, we have a y value, so we can use point slope. So y minus a -4 equals our slope, which is the derivative function, times x plus 1. So this is y plus 4 equals 3x squared plus 4 times x plus 1. Well, we have too many variables here. We have x squared and we have y. So can we make it so it's all in terms of x or all in terms of y? Well, the easier of the two is let y equal x cubed plus 4x. So where we see y, I'm going to put x cubed plus 4x. So now I have x cubed plus 4x plus 4. And I'm going to multiply the right-hand side. Gives me 3x cubed plus 3x squared plus 4x plus 4. And conveniently, the 4x's and the 4's cancel out. So I'm left with x cubed equals 3x cubed plus 3x squared. I'm going to move the x cubed over. So I get 2x cubed plus 3x squared. I'm going to factor out an x squared. I get 2x plus 3. And my x values are 0 and -3/2, which you can see from here. Let's try to make that -1/2. There it is, pretty close. So there's our first x value, and our second x value is 0 and -1.5. So we want to find the equation of the 2 tangent lines. So in order to find the equation of the 2 tangent lines, again, we need an x value and a y value and a slope. Well, we already have an x and a y value. I just need to know what is the slope of the equation at x equals 0. So let's just scroll down a little bit here. And our derivative, I'll rewrite it. Our derivative is 3x squared plus 4. So the derivative at 0 is going to be 3 squared plus 4, which is equal to 4. So there's my slope. The x value and y value that I have is -1, -4. I could use this x value, plug it into the function, figure out what that y value is, but that's just extra work. I already have an x and a y value. I just needed to know what is the slope that goes through x equals 0. Since this is the point that's on the curve, so this is the derivative function. This generates the slopes for this function, and this is a point that's on the curve. Negative, if I plugged in -1, that would make sense because this point is not on this curve, so I don't really want to know what the derivative is at x equals -1. So I have y plus 4 equals 4x plus 1. I get y equals 4x plus 4 minus 4, which gives me y equals 4x. So that's the equation of my first tangent line. My second tangent line, I need to determine the derivative at -3/2, because -3/2 is on the curve. So I get 3 -3/2 squared plus 4, courtesy of my calculator, is equal to 43/4. So again, I'm going to use the -1, -4 because I know this point is on the line. This is the derivative at -3/2, which is an x value that's on the curve. So y plus 4 equals 43/4 x plus 1. I get y equals 43/4 x plus 43/4 minus 4. And again, courtesy of my calculator, I get plus 27/4. So these are the equation of the two tangent lines that go through the point -1, -4 to the function x cubed plus 4x.